Cats and kittens. Today we're going to be reading about tides.
Exploring tides, reading and comprehension questions. So in this video, that's what we're going to be doing. So for this one, I'm looking at this reading here, Exploring Tides. You have the PDF version. I'm just going to read the beginning here and then read over the questions. Exploring tides, how Earth's waters rise and fall. Coastal waters rise and fall each day. Have you ever spent a day at a beach along the ocean? Perhaps you placed your blanket and beach chairs in the sand close to the water's edge. An hour later, you may have needed to move your blanket and chairs to keep the advancing waters from washing them away. The water level on coastlines varies with the time of day. This periodic rising and falling of the water level of the ocean is called the tide. The water level along the coastline at high tide, the water level along a coast is highest at high tide, submerging parts of the coastline. The water level is lowest at low tide, exposing more of the coastline. What in the world could cause such dramatic changes in the ocean's level? The answer is nothing in this world. Read on to find out how out-of-this-world objects cause tides. So it says here on the sidebar to set a purpose. My purpose for reading is blank. So our main purpose is going to be straightforward, answering these comprehension questions. But we want to be more specific. So let's look at these comprehension questions and read them over and see what we need to do. 1. Most coastlines on Earth experience 2 high tides each day because of. So why are there 2 high tides each day? 2. Which factor affects the tidal range in a specific place? So that one already is a question. Which factor affects the tidal range in a specific place? 3. What is the purpose of the labels on the map on page 105? So I turn back to page 105 and I look at the map and I look at the labels to think what is the purpose. Here is the map. The labels there tell me that Portland, Maine has a high tide at 9:36 p.m. and a low tide at 3:15 p.m. Boston, Massachusetts has a high tide at 9:41 p.m. and a low tide at 3:23 p.m. The caption says a place farther east along a coastline experiences high and low tides earlier in the day. This is because it passes through the tidal bulge first. Exact times for high and low tides change daily. So it talks about a place further east, experiencing high and low tides earlier in the day, talks about a tidal bulge, I'm not sure what that is, and talks about Portland, Maine, Boston, high tides and low tides. That's specifically what the labels say. When I look through this question and I think about this, it's talking about different locations and their tides occurring. It's talking about Portland and Boston, but it's not talking about tidal range. It doesn't even mention tidal range. And it's not talking about what time it is. So it's kind of looking at tides and when they occur. That's probably the most likely choice here. All right, in diagram 2 on page 107, why is the water on either side of the dam at different levels? So I look specifically at page 107, and I'm looking specifically at diagram 2. Underneath diagram 2, you can see it's kind of like a bridge here, and I see a car going over, and it's kind of cut away here so I can see inside, and I see the water's at this level, slower there. When the tide begins to lower, the gates close, trapping water behind the dam. So when the tide begins to lower, the gates close, trapping water behind the dam. So water gets trapped behind the dam, and it says, why is water on either side of the dam at different levels? So something to do with it being the gates closing and water getting trapped when the tide's lower, right? When the tide begins lower. So there's only one answer choice that actually makes any sense based on that section there. So you got to read carefully, read these answer choices, because 3 and 4 have some tricky choices in there that are trying to trick us. But if you just look at the text feature, you could probably already answer those without having read the text. 5 and 6, these are questions that are going to require a little bit extra work. Which sentence best explains how exploring tides and sea fever are alike? So I said we're going to read Exploring Tides, but we're also going to have to read this poem called Sea Fever to figure out how they're alike. 6. Based on what you learned in Exploring Tides, what is probably happening in line 5 of Sea Fever. So Sea Fever is shorter, it's only a page. So what I'm going to do is read this first, and then when I get to questions 5 and 6, read this poem and try to figure out how they connect. 7. Which definition most accurately explains the scientific term gravity? It's probably right here in the text, something to help me out. 8. Based on context clues on page 107, you can infer that a renewable energy source is one that blanks. So I can actually go to page 107. I can look for a bold word. I don't see the bold word renewable energy source. I'm going to scan for it. I see renewable source of energy. Okay. Also, tides are a renewable source of energy, semicolon. The tides are not used up in the process. So the tides are not used up. So something not being used up would likely be a good choice. When I look at these things, there's one choice that talks about that. So kind of already figured out question 3, 4, and 8. Now let's read Exploring the Tides, trying to find answers to 1, 2, 7, and thinking about the overall picture for 5 and 6 when we read that other part. So, 104, the gravity of the moon and the sun causes tides. Over 2,000 years ago, people knew that the moon and the tide were related, but 1,700 years passed before the connection was explained in terms of modern science. In the year 1687, Sir Isaac Newton developed his theories of gravity and linked the tide to the moon's gravitational pull. Gravity is a force of attraction between objects. Oh, that talks about gravity is a force of attraction between objects. Earth's gravity pulls things towards its center, including you. The gravity of the sun and the gravity of the moon also pull on objects on Earth. In response to the moon's gravitational pull, Earth's water bulges on the side facing the moon. The moon's gravity also pulls on Earth itself. Earth gets pulled toward the moon, leaving a second bulge of water on the side of Earth facing away from the moon. The sun's gravity pulls too, but with less effect because the sun is so far away. All right. High and low tide occur each day. This diagram below shows the two bulges of the ocean water, one on the side of Earth closest to moon, the other on the opposite side of Earth. At these bulges, it is high tide. Between the two bulges are dips. At these dips, it is low tide. As Earth rotates, different parts of it pass through the bulges and the dips. As a result, most places experience 2 high tides and 2 low tides each day. Oh, I see, like high tide and low tide. So you can see, like, here's the moon. So there's a bulge here, and then there's a bulge opposite that, and so you have low tide on the sides that aren't facing the moon, and then the part that is facing the moon has a high tide, and the North Pole is right here at the top, and then the part away is the low tide. So the direct high tide is the moon's gravity pulls most strongly on the side of the Earth facing the moon. In response, Earth's waters bulge on the side. The indirect high tide, the moon's gravity also pulls on Earth itself. Earth is pulled toward the moon, leaving behind a bulge of water on the side farthest from the moon. So like the Earth, this water gets pulled the strongest, then the Earth gets pulled second strongest, and this gets pulled the least strongest, so it's kind of left behind. The timing of high and low tides at one location on a coast may differ from the timing at other locations along that coast. As you can see on the map of the coastline of New England, the tides occur later as you move west along the coastline. As Earth rotates, the easternmost points on a coastline will pass through the tidal bulge before places farther west on the same coastline. The timing of high and low tides is not the only way that tides can differ along a coastline. Some places experience higher high tides and lower low tides than other places. The shape of the land above and below the water affects tidal ranges. So the range, how far in the tide goes, is tidal range. Now again, this image is only talking about the high tide times, the time of your high and low tide. It's not talking about the range. A tidal range is the difference in height between high tide and between a high tide and the next low tide. The tidal range is greater in a narrow bay than on a wide open shore. For example, the narrow harbor of Limestone, England, has a very large tidal range. A coastline with a steeply sloped ocean floor has a larger tidal range than a coastline with a gradual dropping floor. For example, the coasts of Texas and western Florida have very small tidal ranges because of the gradual slope of the ocean floor there. Okay, so steeper slopes, meaning it gets deeper faster, have a greater tidal range, and then like the lower slopes don't. I don't remember any of the questions talking about that. Over here on the sidebar, it says tidal range has to do with the, not the timing of the tides, the height and depth of the tides. It says the test may ask you about the meaning of a term. If you're unsure, scan the text. So I'd say it has to do with the height and depth of the tides. Tidal range is the difference in height between a high tide and low tide. So yeah, the height and depth, not the similarity or the frequency. Okay, so yeah, we only have 2 pages left. There's not too much. All right, 106. Tides can be used to generate electricity. So like 106 and 107, I think are supposed to be read kind of like this. Tides can be used to generate electricity. The energy of tides can be used to generate electricity. A tidal dam is built near a coast in the path of tidal waters. The waters flow in during high tide. The water flows in during high tide and is trapped behind the gates of the dam. Then, when tide is low, the gates open and the trapped water rushes out. As the water flows out, it spins turbines that power electric generators. Tidal dams cause much less pollution than many other methods of generating electricity. Also, tides are a renewable source of energy. The tides are not used up in the process. However, tidal dams have some drawbacks. Few places in the world are actually suitable for such dams. Another problem is that the times of day when tidal dams generate electricity might not be the times of day when people most need electricity. Tidal dams also sometimes block the paths of migrating fish and might hurt marine life by altering the regular flow of water. So we look at this whole thing down here. 1, it says open ocean, the shore, you have a gate. The dam's gates are opening as the tide rises. Note that the water level is the same on both sides. So the tide rises, water level is the same. 2, when the tide begins to lower, the gates close, trapping water behind the dam. So over here, the tide's lowering, so the water level goes down. Here, the tide stays high. 3, at low tide, the gates open and the water rushes out, spinning turbines that generate electricity. So now we have lower water over here, higher here, but they open it up. The water goes through here, rushing through, back out, and it spins the turbines to generate electricity. So now, we're on to these questions. 1, most coastlines on Earth experience 2 high tides each day because of... So it's talking mainly because of the gravity of the sun and the moon. So only one of these choices even has the word gravity, and the rest of them don't necessarily make sense, except for the other one talking about rotation. So now, when the one that says gravity is talking about sun's gravity. So the sun's gravity was not really that big of a factor in here. So when we're thinking about the 2 high tides, I think about those tidal bulges. And then it says here that at these bulges it's high tide. So as a result, most places experience 2 high tides and 2 low tides. So this is right here talking about it on page 104. At these bulges is high tide between these dips. As Earth rotates, different parts of it pass through the bulges and dips. So it's talking right there about how Earth rotating is what really is causing that. In addition to the moon's gravity, nothing to do with the sun. All right. 2, which factor affects the tidal range in a specific place? So the tidal range in a specific place was affected by, I talked about it back here on page 105. Tidal range is the difference in height. The tidal range is greater in a narrow bay than a wide open shore. Okay, a coastline with steeply sloped ocean floor has a larger tidal range. So the shape of the ocean floor and the shape of the land, if it's like a bay, and then also like what the ocean floor is. So the shape of the land above and below. What's the purpose of the labels in the map on page 105? Again, going back to page 105, we look at this map is showing us the timing of the tides in Maine and in Portland, Maine, and Boston, Massachusetts. So when I look at these, it's comparing when, or the time when tides occur. It's not talking about the difference in times, it's just telling me when they occur. It's comparing when they occur in different locations in terms of east or west. On page 107, why is the water on each side of the dam at different levels? This one's a right there question. It literally tells us in the caption, when the tide begins to lower, the gates close, trapping water behind the dam. And that's going to be our answer there. 5. Which sentence best explains how exploring the tides and sea fever are like? Oh, I forgot to change this. So, which tractor affects tidal range specific place? Did that. Talked about 3 and 4 with our text features. Now we're going to go on to 5 and 6. Which sentence best explains how exploring the tides and sea fever are alike, and then based on what you learned, what is probably have in line 5. So, let's read Sea Fever. It's just one page, a little poem. Sea Fever by John Masefield. I must go down to the seas again, to the lonely sea in the sky. And all I ask is a tall ship and a star to steer her by. And the wheels kick and the wind's song and the white sails shaking. And a gray mist on the sea's face and a gray dawn breaking. I must go down to the seas again, for the call of the running tide is a wild call and a clear call that may not be denied. And all I ask is a windy day with the white clouds flying, and the flung spray and the brown splume and the seagulls crying. I must go down to the seas again, to the vagrant gypsy life, to the gull's way and the whale's way, where the wind's like a whetted knife. And all I ask is a merry yarn from a laughing fellow rover, and a quiet sleep and a sweet dream when the long trick's over. Okay, so this is talking about, I don't want to read this again, but spume, foam, liquid. Talking about some guy kind of going out on the sea. I think he's like looking for wind, so he wants like a sailboat. He's going out on the ocean. So what's something that best explains when it's talking about different things about the ocean? So I think they're both talking about like the ocean. I mean, I think the scientific process is more so in exploring tides. Sea fever is not super scientific about it. Sea fever is talking more about the emotional things. Yeah. So, yeah, I'd say they're both talking about the ocean. Based on what you learned in exploring tides, what is probably happening in line 5 of Sea Fever. So in Sea Fever, line 5 says, I must go down to the seas again for the call of the running tide. So I'd have to say it's probably doing something along the line of the tide is running. So maybe like it's running away. So it's changing in some way. I don't know if it's running in or out, but I'd say it's probably changing in some way. That would be my guess there. 7, what definition actually explains the scientific term gravity? That was right there on page, right at the beginning, page 104 in the first paragraph. Earth's gravity pulls things towards its center. Gravity is a force of attraction between two objects. So, which most accurately explains the scientific term gravity. So both of those are choices. So then you say the scientific term, I would just go with the one that doesn't say Earth's gravity, but just says gravity is a force of attraction between two objects. It's probably your most accurate definition. Based on the context clues on page 107, what can you infer? Renewable energy sources won that. And I've already talked about that. I think I already know the answer. We can change the slide. There we go. And renewable. Also, tides are a renewable source of energy. The tides are not used up in the process. I think that sentence right there with the semicolon in there gives you right what you need to infer. And that's all 8 questions. So, didn't quite give you the answers, but hopefully that helps.